Hi, in today's video we talk about how to perform degradation tests and plot degradation curves, specifically in the context of tissue engineering. When we design scaffolds or hydrogels for, let's say, cartilage repair, wound healing, or bone reconstruction, it's not enough that they just look good or feel right. We need to know how they break down over time. Proper degradation profile helps us match the material's lifetime with the tissue regeneration process and avoid issues like premature failure or long-time residue in the body. The first step is to prepare a list of all your samples based on your variables and enter them in a single column in your Excel file. For example, if your samples are 3D printed, may have used different patterns, and each of those patterns may have a different degradation behavior. In addition to the pattern, you may have used different material compositions in your samples, or some samples may be cross-linked. All of these factors need to be reflected in the number of samples so you can draw the best possible conclusions from your experiment. This means that for each pattern, you should have separate samples for all material compositions, and for each composition, separate samples for both cross-linked and non-cross-linked types. Or in my case, if your scaffolds are electrospun, they may have been produced in two different forms, random and aligned, and each of these may have been fabricated with different material percentages, and each percentage again in both cross-linked and non-cross-linked forms. Make sure that for each specific samples defined by a unique set of variables, you have 3 replicates. Having 3 specimens for each sample helps you account for possible errors during the process. Also make sure that the dimensions and weight of samples are equal and comparable, so that the only factors affecting degradation behavior are the variable components you mentioned. You can use ASTM standards as a reference. Usually PBS solution is used in this test. Prepare it and easily dissolve the appropriate amount of PBS powder or tablets in water. Make sure to recur the concentration of the solution so that you can use the same concentration throughout the experiment. The proper way to do this is to use a separate container for each sample. It could be dishes or anything else. Add the same fixed volume of PBS to all containers and then place each sample into its own container. From this moment, which we call day 0, the degradation process of your scaffolds begins. At defined intervals, for example every 3 days or every 7 days, you should replace the PBS in the containers. Collect degradation data at specific time points, which for typical polymer tests are often day 1, 3, 5, 7, 14, 21, and 28. The scaffolds are weighed. You can also measure pH changes at time as the weight measurements. This allows you to see whether the byproducts released from the scaffolds are making the medium more acidic or more basic. Whenever you reach one of the predetermined time points, first measure pH of each sample in its medium. Then remove the scaffolds from the containers, dry them, and weigh them. In the Excel file I mentioned earlier, record the weights under the corresponding day. After you finish, return the scaffolds to the degradation medium. After the final day weighing, you now have a complete Excel sheet of raw data that you can convert into graphs. Remember not to discard the remaining samples immediately, because you can use them under the SEM observation as degraded surfaces. You can easily process and plot the data using Excel, GraphPad Prism, or even AI tools like Cloud. Before turning the data into graphs, it's a good idea to carefully check each replicate. If one shows an unjustifiable or very different behavior, you can ignore it. Then calculate the average of the remaining replicates so that for each sample at each time point, you have a single mean value. It's better to convert all the weights percentage of mass remaining relative to the initial weight, so everything is comparable. As an example, here you can see a set of raw data that I've imported into GraphPad Prism. Choose names for each data. In this sheet, your data will be converted into graphs. Change the graph type. For example, you can switch it to a bar chart. By right-clicking and selecting this option, you can adjust the colors and other graphical settings of the plot. Based on the number of replicates you have, you can calculate the standard deviation (SD) for each sample and add error bars to your graph. A steeper slope means the scaffold is degrading faster, while a gentler slope indicates a slower, more controlled degradation. Ideally, you want a profile that matches the tissue regeneration rate, not something that disappears too fast or stays too long. Among AI tools, I recommend Cloud for plotting because it's very accurate with graphs. And with a simple prompt, it can generate an HTML file of your plot. Cloud can also use its coding tools to easily modify any part of the graph that needs changes, from numerical adjustments to graphical refinements. I hope this tutorial was helpful for you. Thanks for watching.